Okay. Oddly, this says Precal BC. Don't worry about that. I just realized that right now. Well, obviously we're at level Precalculus. Okay. So just some terminology. Can you get your notes out, please? Thanks, appreciate it. Okay. So going back to geometry, which I assume you guys probably took about 3 years ago, maybe in 8th grade or freshman year, or 10th grade. I don't know when you guys probably took it. What does it mean when two angles are complementary? So that term complementary, do you guys remember what that term means? Stella, go ahead. Actually lower. Yeah, so we do either 90 or 180 in geometry, but complementary is when they add to 90. Supplements to 180, right? So two angles, but you're on the right track. Two angles that add. Let me just write as a text box. It's easier. Here we go. It's when two angles add to 90 degrees. That's all. That's what it means to be complementary. Now, one thing that I didn't make clear to you guys yet, but I'm going to make clear right now. When you look at sine versus cosine, the CO part, the co part, is actually abbreviated for the word complementary. That is hard to read. Let's redo that. Let's go blue. That's actually abbreviated for the word complementary. What's the O? The CO, the whole part. The whole part's abbreviated for. Okay, the C and the O, not just the C. There you go. Here, the whole thing. Okay, thanks, Eric. All right. So no worries, all good. Because the arrow's right next to the C. It's confusing. It's my fault. So what's going to happen is that let's say we have a right triangle here. Let's say it calls like A, angle B, and angle C. And let's make up some sides. What are some typical sides you have for a right triangle that would satisfy the Pythagorean theorem? But what are some like common sides we could see? Side lengths. Not angles, side lengths. 3, 4, 5, yeah, that could work. 3, 4, 5 could work. Were you giving an angle or? There are other ones too, but we'll go 3, 4, 5. Okay. Now, what if I computed the sine of angle A? Remember SOHCAHTOA, right? So I took the sine of angle A. Remember, sine is what? Opposite of hypotenuse. What's the opposite side of angle A here? What's my hypotenuse? So 4/5, right? Okay. Now let's look at cosine of angle B. Angle B is right here. Now, because we're doing cosine, on adjacent hypotenuse. What's adjacent to angle B here? Now, what's the hypotenuse again? 4/5. It's not so. The sine of angle A is the same thing as the cosine of angle B. The sine of angle A happens to be identical, and it's not a coincidence. Now let's ask ourselves the next question. How are angle A and B related? What do they add up to? 90. They have to, right? Because if that's 90, how much do you have left for the other two angles? 90, right? So A and B, angle A and angle B are complements of each other. Because they have the 90. That's why cosine is considered the complement of sine. Because what did I do here? I took sine of an angle, which is 4/5. And I took the complement of the sine of a complement angle, and that's also 4/5. So this we could always expect to happen. Whenever you have two angles that add up to 90, the sine of one angle and the cosine of the other are always going to equal each other. So let me actually write that out, because that's actually kind of key what I just said. I'll write it off to the side here. If two angles, come on, let's try again. If two angles add to 90 degrees, then the sine of one of those angles equals the cosine of the other angle. So if two angles add to 90 degrees, then the sine of one of those angles equals the cosine of the other angle. Also, the same type of thinking can be applied to secant versus cosecant, and tangent versus cotangents. The same type of thing can be applied to that as well, because the co is abbreviated for there complement, right? Complement, yeah. Okay, not just the co, right? The co is just abbreviated for complement. So does that make sense? Yeah, and we just saw a really quick example. We know this is true. We know 3, 4, 5 makes sense. 9 plus 16 is 25. I take the sine of angle A, got 4/5. The cosine of angle B also got 4/5. Angles A and B are complements. They have 90. Duh, because that's 90. You have 90 left to the 2. So we can make that connection that sine angle A equals cosine B as long as A and B add to 90. Exactly. So let me move this off to the corner here. So let's look at what's in the yellow box. In the yellow box, these are called co-function identities because they're always made identical. This will always be true regardless of what theta is. So if I'm dealing with degrees, with the 90 degrees here, sine theta equals cosine 90 minus theta, or cosine theta equals sine 90 minus theta. Theta with 30 degrees, then that would be 60. Or if that was 60, that'd be 30. Or if that were like 40, that'd be 50, and so forth. And you can do the same thing with tangent and cotangent and secant. By the way, you don't have to use degrees, you use radians too. If you want to replace 90 with pi over 2, go ahead. Then you're using radians if you wanted to. Same thing could work. Questions so far? Cool? Okay, let's keep moving. So example 1 should be pretty easy. Example 1 just saying, hey, find the co-function with the same value as a given expression. So the co-function is going to be cosine here, and this will be secant. So the corresponding co-function of sine is cosine, the corresponding co-function of cosecant, secant. And what am I going to put in here? The complement of 72 degrees. And what I'm going to put in here, the complement of pi over 3. Okay, we'll start with part A. What's the complement of 72 degrees? Well, 18. That's it. Yeah, thank you, Dan. Just 18. Yep. 18 degrees. One of your classmates. 18. Okay. All right. Okay. Pi over 3 is a little tricky. Does that make sense? 18 degrees, right? Because 18 plus 72 is 90, right? That's all. 18 plus 72 is 90. Now, pi over 3, it's a little harder to work with radians. We're still trying to get our bearings straight with radians. But if you think about it, you have a unit circle. That's same as 60 degrees, right? We've talked about that. You guys have a unit circle, right? If you locate pi over 3, you'll see it's 60 degrees. What's the complement of 60? 30. And then what's 30 in radians? Good, thank you, so 5 or 6. I think Eric. 5 or 6. Yeah, same as 60. So the complement or pi over 6. That's all. So those are going to be equivalent. If I were to punch in sine 72 in a calculator, actually I'll pull up a calculator right now. If I were to be in degree mode. So by the way, make sure you're mindful what mode you're in. So if I did sine of 72 and cosine of 18, not a coincidence, the same thing. Or make sure you switch the mode if you go to radians. If I do cosecant, which is going to be 1 over sine, if I did 1 over sine pi over 3, and then if I did sine, sorry, 1 over cosine, my bad, 1 over cosine of pi over 6, I get the same thing. So it's not a coincidence. I get the same thing. Okay. So questions, we're okay on example 1? All right. The next few problems are all going to be kind of the same thing. They're all word problems dealing with trigonometry. So we examples 2, 3, 4, 5, and 7 are going to be very repetitive. So just bear with me. I mean, they're kind of good problems, but it's going to be very repetitive. First off, angles of elevation and depression. I'm guessing you may have done some geometry, but probably forgot. If you think about elevation, when you hear the word elevation, what do you think of? When you think of elevation? Up. When you think of depression, what do you think? Down, right? So in trigonometry, angle of elevation would be how far you have to look up to see something. So if I'm standing outside, like say in the middle of Homer and McGaney, and I look at the top of the main building where the bell tower is, I have to tilt my head up to look up to the top of that building, right? So that would be an angle of elevation. But if I'm standing on the top of the main building, I'm looking down at the people on the ground between Homer and McGaney, I got to tilt my head down, right? That'd be angle of depression. Think of elevation up, like an elevator goes up, and elevators go down too. But to elevate means to go up, to depress means go down. So, yeah. I don't know. Okay. So anyway, elevation, depression. There we go. So it's basically you take the horizontal line of sight, and how far do you have to tilt your head up to look at the object, or how far you have to tilt your head down to look at the object. Those are elevation and depression, respectively. So let's try some problems. Let's look at this one here. So a surveyor, we'll say Ms. York, she's a surveyor. She's at Washington, D.C., and she's checking out the Washington Monument. Now, let me give you the steps that you'll need to do these problems. It's really a 3-step process. You'll need a diagram. You'll need an equation. You'll need to solve. So it's really a 3-step process. Diagram, equation, solve. So the diagrams shouldn't be too hard. I mean, if you have one, you know, that's great, but sometimes you're not given one. Okay, so let's say this is the Washington Monument. And how far is she standing from it? And what do I want to find? So I'll put X there. And then the angle of elevation is right here, which is 70.3 degrees. So I've got my angle. I've got one side, I've got another side. So the diagram's done. We could check that off. Now, an equation. Clearly, we're dealing with trig, right? So we have 3 options. Which of these 3 options do you think I should use? Given what I want to find and given what I know. Which of these 3 would make the most sense? Which of these 3 I should use? TOA. Good. Well, Tia, do you see why we do TOA? No. Okay. What do I want to find? X, right? Yeah. How does X relate to this? Is it opposite, adjacent, or hypotenuse? Opposite. The 115 is it opposite, adjacent, or hypotenuse? Adjacent. So I need O and A. That's O and H. That's A and H. O and A. Bingo. I don't want the hypotenuse at all because, first of all, I'm not being asked to find it, and I'm not given any information about it. We actually don't care about the hypotenuse in this problem. We only care about O and A. So you're going to have to use TOA. We have to use TOA. So my equation will be tangent of that angle equals x over 115. So check, my equation set. So you have to figure out which equation to use. So you got to know your SOHCAHTOA. You got to know that down cold. Again, that was opposite. That was adjacent. All right, last step, solve. How would I solve this? What would I do? How would I get x by itself? Multiply by 115. Awesome, very good. I like that. Outstanding. And then you just work it out. Now, of course, you need a calculator. And please, 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 please be in the right mode. If you're in the wrong mode, you will get a wrong answer.
What's the right mode? How do I change it?
So
This is our angle, right? And we see degree symbol. Yeah. Hence I need to be in. Degrees are rated. Degrees. If I don't see a degree symbol, you do degrees. If I see a degree symbol, be degrees. And that's what one, three, four, six.
Great question. You go to mode. You go to mode. And you go down and you switch over to degrees. To switch over, just select it and hit enter. So they get 115 times tan of 78.3. And there you go. Oh, I have a mistake. Okay, wait a minute, my first mistake. Okay. Am I in the right mode? I'm in the wrong mode. I forgot. Actually, I thought I switched it. That's not right. Okay. Anyway, I thought I switched it. So
This is good. I'm actually glad I did this. Can it only be negative 28 feet? Oh, I think it's really negative. That's weird, right?
Have to be the fresh building.
or I guess, yeah, I guess if you want, it's in the basement, sure. Yeah. Yeah, we have a basement here, right? So let me repeat it and try again. There you go. That seems more reasonable. 5 feet. And we'll just round to for today. We'll round to nearest whole number for all of our questions today. I might specify maybe more accurate. Maybe I might say, give me 1 or 2 decimal places. We'll just do whole numbers. That's fine. Okay, question on how I did that one? We're okay? We're good? Sure, that's fine. I mean, it might be a little slower because you have to switch to scientific mode.
I wanted to get.
You don't have a graphic calculator?
No, I do, but my brother like low key took it to college.
Oh yeah, okay.
Now it's gone, and I was like, why did you take my backpack?
Okay, good.
This is so cool. Full graphic calculator.
There we go. These phones are pretty awesome. All right, let's keep moving. All right, this one, it's a little bit, well, I wouldn't say it's challenging, it's a little more unique. So you have to be mindful of when you measure angles of elevation, like where are you measuring from? Like,
I measured from your feet on the ground, or from your eyes. Like you have to figure out
where am I measuring my angle of elevation? Apparently, you got some person here. They're looking at the top of this building. This person, because maybe like his telescope or whatever his device he's using, is 5 feet off the ground, or his eyesight is 5 feet off the ground. Yeah, pretty short, right? So what we're gonna have to do is we're gonna have to make a right triangle again, but we're gonna use A as the opposite side and 300 as my adjacent. So 300 will be my adjacent. And that'll be my opposite. So diagram, check. That was already provided. Equation, let's make it. How do I make my equation here? I have O and A. So I use tangent again, right? So we use tangent again. And tangent, what's my angle? 22 degrees. Equals my opposite, which is letter A, and my adjacent, which is 300. And I solve for A. So what do I get? Let's use the calculator. 300 times tan 22. You should get 121. However,
+5.
y plus 5, Eric, that's good.
Because you're 5 feet up the ground and, I don't know how to describe it.
Well, A didn't take the 5 feet into consideration yet. Yeah.
Yes.
Yeah.
However, the answer is 126, not 121, because the question asks for the height of the building. What we found was the height of the building minus the guy's heights. That's what we found, right? When we measured this, we measured it assuming that going from the line of sight to the top. The line of sight is up or off the ground, 5 feet. That's why I have 5. The top, that should be in there. That's right.
Yeah.
So, okay. It's actually that I don't know. Oh, that's really cool. Let me get that out.
Oh, the numbers.
It's great.
Yeah. It's great. Okay, cool.
It's good.
Huh.
No, my friends won't care. Okay. Oh, teacher friends, there we go. Okay. My colleagues, there we go.
I didn't know you were.
Kind of. What was that? Oh yeah, he's a pilot, right? Yeah, I don't think I'd fly with them. I don't think I would. I don't know. All right, and then we solve. So we took care of it. Yeah, I forgot he is a pilot. I forgot about that. So you get 126. All right, let's keep moving. Any questions about number 3? We're okay? We're good? All right, let's keep moving. Now this one's a little bit more unique. This will be opposite. This will be Jason. We're going to do tan again. But we don't know theta. We don't know the angle. So we're going to say this. Tangent theta so now it's the opposite.
I know both sides. I don't know the angle of elevation. That's my theory about it. The tan theta was 25. Now, this I've not taught you guys yet.
You need to isolate theta. I'll write down, here's a text box. I'll show you right now.
Oh. So would it be cotangent?
So to isolate theta, we need to use an inverse trig function. So you hit second tan or tan raised to -1 power.
So what you're going to do is you're going to say this. Theta equals tan raised to the -1 power of 20/25. This is no different than, remember doing these kind of problems back in the day, like x squared equals 4? And how would you solve that? What would you do to both sides? Right, and why would you square root?
The square root is the inverse of squaring. What's the inverse of tangent? It's called inverse tan. So it's just an inverse tan.
And how do you locate it? You hit second tan. So I'm going to my calculator. Second tan 21/25. 40 degrees.
And
But you have to hit second tan. Or give a tan 81 in your fan sheet. Yeah, that works too. Yeah, so
8 tan.
I have the calculator right there.
Good.
That's not good.
No.
No, it's your side. Yeah, that's not good. Yeah. Well,
I hate this thing.
well, first of all, $1,000.
You could be just giving away.
So it's 40 degrees, right?
40 degrees, yeah. Okay, questions on this one? No, what you do is you have to second tan. You don't. It's a built-in feature in the calculator. Just divide. All right, let's keep moving. All right, now we don't have a diagram, so we got to draw one. Sounds good to me. Okay, so you have an airplane. It's 1,200 feet above the ground. It's making its approach to SFO. The runway is, sorry, the airplane's 700 feet above the ground, and the runway is 1,200 feet away, horizontally. Got it. So here's the airplane. Here's your airplane. Here's the runway. And then here is the lovely bay. Because as you guys know, there's water right next to the runway. Takes actually a special, I think, license to land a plane in SFO from right here. Takes a lot. Actually, I think the scariest one's the one in San Diego. You guys seen the airport in San Diego?
Yeah.
Those get so darn close to the buildings.
I know exactly.
That in San Jose, but San Diego I think is even closer. Yeah, it's so ridiculously close.
Would you let
Gilmore? No.
Is that a hard no?
That's a hard no.
No way.
No, no. All right. Actually, one of my former students, he went, I think he went to Mount View High School. He's now a commercial pilot, which is kind of, he went to the Air Force Academy.
You trust him?
I would trust him because he's younger. I know. Hey, I'm just saying, like, well, okay, my dad's 78, pardon my language, he drives like shit, and parks like shit. And then my father-in-law, like, he is like just really bad at just drives like a maniac. So yeah, once you get past my uncle's 80, my cousin took his license away from him. Like he just can't drive anymore. So yeah, my back.
Backseat driver.
Like his
Was
son
that-
was driving, they were driving back.
No, I'm usually the driver. So I didn't know what that meant because I'm usually the one who drives. So
Oh yeah, it's kind of me. I
Yeah.
have my
You're a
kids, my
backseat
aunt,
driver.
my
Yeah.
friend.
yeah. Anyway. Okay. So anyway, sorry for the distraction. let's talk about this problem here. So you got 700 and 1,200 because you're 7 feet off the ground, 1,200 feet away. Now, here's the part that's a little tricky. One angle depression. That's the angle depression. Because clearly, for the plane to land, it has to tilt the nose down, right? To get to, runway. So there's gonna be angle depression. Here's where it gets interesting. That's the same thing. Because if the horizontal line of sight of the airplane is like this would be parallel to the ground, or in this case, the water, the bay, right? So these would be parallel. So if that's theta, that's gotta be theta. Remember alternate angles, parallel lines, right? From geometry. So now, tangent again. We're gonna do tangent again. I know. Well, sorry to burst your bubble, but we're gonna do tangent one more time after this. That's all right. It's all good. We could do a problem with the kite where you're looking at like how much string, and that could be the hypotenuse. Yeah.
Were you the guy that came in late?
Okay. So there we go. The equals inverse of that. And what's that going to be?
Some changes went to the second.
30 degrees. There we go. So 30 degrees. Any question on this one? We're good? Maybe move on? We'll round to the nearest whole number. That's fine. All right. I'm going to skip number 6 for now. We'll come back to it in a few minutes. Let's look at example 7. All right. We'll come back to it in a sec. All right, so let's read through this problem.
So apparently, you're right, your friend's right here, you're on hot air balloon. Right now, your stern is the top here. After 1 minute, you go even higher up. The angle elevation is 30 degrees. After 1 minute, the angle elevation goes to.
So what we have to do, the diagram is done. So we're good there. Diagram check. But now we're going to need 2 equations. Equations we're going to need. What are my equations going to be? Well, okay. Not yet. So tangent again. Tangent of 31.7 degrees. If I focus on that little triangle, what I'm going to put on the other side. What do you guys think? What am I going to put on the other side? If I focus on the small triangle.
So the small triangle is the angle of elevation 31.7. A over 100. Thank you.
Thank you, Diana. A over 100. Now, big one. Let's look at a big triangle. I have another right triangle. That angle of elevation 76.2 degrees because you're told so. And the diagram shows that. And how am I going to write? Well, I'm going to write on the other side there. B over 100. Thank you again. B over 100.
So the 76.2, just so you know, includes the 30.7. 76.2 is from the ground to that. That last side. So it includes the 30.7. It's already wrapped into it.
Well, let's figure out A and B. Okay, so you guys should know what to do now. We've done this 4 times already. So you got to multiply by 100. And then you work those out. So you need to get a calculator here. Actually, let me just. Yeah, 100 times tan of 31.7. 61 point, or we'll say 62. And next one, 76. We'll say 407. So the question is, how far did he travel? So
if you started here, after 1 minute, you go up to here. We want to know how far you come in that 1 minute. That 1 minute.
So you got to do B minus A. Does that make sense why I'm doing B minus A? Because you're asked to figure out how far you're traveling right in that 1 minute. Because you started when you're already off the ground, and then after 1 minute, you're even higher off the ground, right? So 407 minus 62, you should get, what is that? 345, thanks. So apparently the hot air balloons traveled 345 feet in that 1 minute. And that 1 minute went that far. Okay. So yeah, it's a lot of word problems, but I think by now, hopefully the repetition helps. You guys see what to do. So again, have a diagram. If you have one, great, use it. If you don't, make one. Develop your equations using SOHCAHTOA. Solve just using the calculator. So, okay, we're good. All right. Before I go over the homework, let's talk about example 6, because example 6 is pretty close to what you're going to see on the homework check-in very soon. You're going to want to use a unit circle.
Oh, this is good. Are we doing this in the homework check?
Something kind of like it. It won't be quite this involved. And remember, sine is y, cosine is x, tangent is y over x.
We'll have our circles, right?
You could use, and you could use your homework too, and your notes. So sine is y, cosine is x, tangent is y over x. Now, pi over 3. Let's work each of these out. Actually, let me pull up the unit circle. I think I have one right here. Okay.
Where do you see pi over 3? 60 degrees.
And where are the coordinates that go with it? These right here. But I want the what I want. What was I asking for? So I want the y. So I want the y. Yeah. So I'm going to go root 3 over 2 times, and it'll be a minus. Okay, let's look at cosine. Pi over 4. Where's pi over 4? Right there. I want cosine, so I want x. That's how you use a circle. Root 2 over 2. Exactly. Exactly. Okay. Then pi over 4, back to the same place again.
The tangent is y over x. So y is root 2 over 2. X is also the same thing. What happens if you divide two things that are the same? So we have 1.
Good. Good. You get root 2 over 2 over root 2 over 2, which of course is 1. So you have root 6 over 4 minus 1. Not that hard. You like that? All right, let's move on to another one. But questions on that one? That was fine? All right, let's do it again. Let's change colors. So 2 times okay, pi over 3. Let's look at that one.
Pi over 3 is right here. And you want tangent, right? So you're going to do root 3 over 2 over 1/2. Right?
It would be root 3, exactly. Good. I think so. Yeah, let me make a little more space here. I need more space. All right. 2 times root 3 over 2 over 1/2 plus cosine pi over 4 is going to be root 2 over 2. We just did that in the previous problem. And then in this case, you're going to do 1/2. If I look at pi over 6,
That's right here. We want y over x. Right? Tangent is y over x. We talked about this, right? Tangent y over x. 1/2 of the root 3 over 2.
clean it up.
Yeah, because it's y over x at pi over 6. And because you're dividing these two, you got to flip the second one. When you flip it, it becomes 1 over root 3.
You could. You could.
Oh.
Yeah. I don't care.
I've just been doing it like 2 or
Yeah, that's called rationalizing the denominator. I know we asked you guys to do it in geometry or algebra or whatever. In this class, I don't care. That's fine. So that's how you express that in radical form. Okay. Okay, questions? No? Okay. Let me go over the answers from the homework. All right. Let me give you all the answers for number 3. And I'll go over any questions you may have. What's that going to be? Cosine 2 pi over 3, that's -1/2. I think that's 0. Cosecant of 4 pi over 3, that's -2 over root 3. Secant of 5 pi over 3, cosine, what's that going to be? -2, I think. Then E, that's going to be, yeah, I'm just going to give you the answers right now. Okay, I think I got all these right. Oh, I lied. That's just 2. Yeah. Okay.
Questions on these 6? Everyone agree? Any questions? So how you do it again? Use your unit circle. Go Dan?
Can you go for D?
D, yeah. So for D, you can have 5 pi over 3. So we locate it, right? That's going to be so that's 5 pi over 3. So we swim over here. The coordinates are this. And because it's secant, that's 1 over cosine. Or 1 over x. So you flip over 1/2. That's 82. That's 82.
All right.
Wait, I think
Questions? No? Yeah, go ahead. Yes, kind of, no?
Dan was asking about the why the answer is 2.
oh, okay.
So 5 pi over 3 got located. And then once at the course, it's secant 1 over cosine 1 over x.
Yeah.
That's why it's right. Okay.
For 4, let's look at 4. So you got 7 pi over 6. 7 pi over 6 is going to be over here. Where are the coordinates there? Oh, let me erase the board. That's going to be negative root 3 over 2 and -1/2.
You understand? Oh.
Okay. All right, so guys, quiet. Let's focus, please. We're almost done before we do the check-in. Thanks. All right. Sine is y coordinate, right? Remember, sine is y, cosine's x. That's y over x. That's 1 over y, 1 over x, and x over y. What's the y coordinate here? -1/2. What's the x coordinate?
Wait.
Oh, mistake? Did that make a mistake?
Wait, is this
Number 4. Number 4. 4.
4?
4.
Okay.
We're at 7 pi over 6, so we need the proper coordinates.
Oh,
Those are my coordinates at 7 pi over 6. Where sine's y, cosine's x, tangent's y over x.
And then flip for the other 3. And that's going to be 1 over root 3. Then you reverse. And secant, if you want, you can also write like this too. Or you could write tangent like √3/3. You can also write like that too. So in terms of rationalizing the denominator,
I don't really care if you leave like this. There's a multiple choice question. It might look like this. You do need to recognize that that's the same as that. So the very
least do need to know how to get there. Okay, questions on 4? And then lastly, let's do 5. Okay, negative pi/2 is right here. That's my negative pi/2. The coordinates are 0, -1. So let's erase this. -1, 0, -1/0, or undefined. So I'll do UND is short. You got flip. And that's just 0. So you just flip them.
How did you start that problem with that?
So negative pi/2 have to, so my angle is negative pi/2.
So I drew it like this. This negatives have to go clockwise. So that's what's over here. So actually, great question you're asking, because we don't see negative pi/2 in the instrument, right?
Yeah.
So we have to go back to the previous class drawing angles. And that's how you draw negative pi/2. Because it's like -90, right? And then so we're coterminal with this part right here. So where are the coordinates here? And then use those coordinates.
So actually the check-in is going to have stuff that you're not going to, so I'll tell you right now, the check-in is going to have angles you won't see on the unit circle. So you have to figure out where, you got to figure out how to draw the angle, find something that's coterminal with what you do see on the unit circle, and then use the proper coordinates. I'll help if you guys get stuck, but that's how the check-in is going to look. Okay. Perfect timing. So I want to start around 12:55. Let me make sure I open it up right now. Give me 1 sec. Let me stop my recording.